in this second part of memory management, we'll be looking at the address binding. Okay, so now we know that a program resides on the disk needs to be brought into the memory in order to be executed. And normally such program is stored in a binary executable file and is kept in an input queue. And in general, we do not know where the program is going to reside in the memory. Okay, so therefore we can assume that the physical address of the program in the memory will start at the location 000. Therefore, if the location is 000 without any support from the hardware or the software, the program must be loaded into the physical address of 000. But it is impractical to have the first physical address of user to always start at a location 000. So therefore, most computer systems will provide a hardware or a software support for the memory management. Okay, so in general, addresses are represented in different ways at a different stages of a program's life. Okay, so you have the program, and in your program you will have lines of codes. Okay, so how do we actually identify the codes is through the addresses, and these addresses are known as either symbolic address, relocatable addresses, or the absolute address. Okay, so addresses in the source program are generally symbolic address. Okay, so for example, you have your first line is variable count. Okay, so that is the symbolic address. And then a compiler will typically bind this symbolic address, okay, that coding, that statement coding, into a relocatable addresses. For example, it is 14 bytes from beginning of this module. Okay, so as I said earlier in a much more earlier example, for example, you have programs and so you have lines of program. So each program are numbered. Okay, line 1, line 2, line 3 and so on. Okay, each codes are numbered. So that is the relocatable addresses. And linker or loader will bind the relocatable addresses to the absolute address. So absolute address is the actual address that is in the memory, that is in the physical memory. And each binding maps one address space to another address space. Okay, so address binding is actually when these addresses are mapped, are bind to the physical address in the memory. Okay, so binding of instructions and data to the memory. Address binding of instruction and data to memory, it can happen at any of these 3 points in the time. Okay, so address binding may happen during the compile time, it may happen during the load or the execution time. So these are the 3 times where address binding occurs. Okay, so remember address binding is actually to bind the addresses of the codes in the program to the physical address, meaning that where we want these codes to be in the physical memory. Okay, so address binding can happen during the compile time if memory location is known a priori. Okay, so meaning that if during the compile time, the system already knows where this program is going to reside in the memory, so therefore it will do the address binding there. So it will generate the absolute code. Okay, and must recompile code if the starting location changes. So meaning that if there are any changes to the location in the memory, so the system need to compile the program again. Okay, the second one is during the load time. If memory location is not known at compile time and no hardware support is available, relocatable code must be generated. So meaning that now it has to create the relocatable code. Next, only it will bind that relocatable code into the physical memory. Okay, so another binding of instruction can be address binding can also be done during the execution time. Okay, binding is delayed until the runtime if the process can move during its execution, meaning that it can move from one memory location to another memory location. So sometimes we need to, the system need to move the program codes from one location to another location in the physical memory. So for this, the address binding will be done during the execution time. Okay, so these are the diagram that shows the multi-step that occurs in processing of a user program. So it shows here that address binding can be done during the compile time, okay, so or during the load time and during the execution time. So if the address binding is done during the load time, then it will have to first generate the relocatable address. If address binding is done during the compile time, then it will need to create the absolute address. Okay, so it will create the absolute address. Okay, or also it can actually bind the address into the memory location during the execution time. Okay, so the process will go through these steps. It goes through the compiler, loader and linker, and address binding can happen at any of these steps. So it can happen during the compile time or load time or execution time. Okay, next is to understand between the logical and physical address space. The concept of a logical address space that is bound to a separate physical address space is central to proper memory management. Okay, so meaning that it is saying here that you must really understand the idea of having the logical address space and the physical address space. Okay, so bear in mind, keep in mind, the logical address space is actually what is generated by the CPU for the program. And the physical address space is the actual location of the program in the memory. Okay, so that is the physical address space, the physical address of the memory. Okay, logical is just what is being defined by the CPU for that particular program. Okay, so logical and physical addresses would be the same in compile time and load time address binding, but it will be differ in execution time address binding. Okay, in that case, the logical address is referred to as virtual address. Okay, so when it is different between the physical and logical address, then the logical address is also known as the virtual address. The logical address space is the set of logical addresses generated by the program, generated by the CPU for the program, and the physical address space is the set of all physical addresses corresponding to a given logical address space. So for the hardware support, it has the memory management unit. So the memory management unit is the hardware device that will map the virtual addresses to the physical address. So when I say virtual addresses, it means that it is the logical address. The user program deals with logical address because we never know where in the memory our program resides. So we can only know the logical addresses. For example, when you compile your program, when you run it, and then when you compile especially, then you can see the error codes, or you can see the compiling error, you can see the compilation report. So it tells the addresses, and that is considered as the logical address. Execution time binding occurs when reference is made to location in memory. Okay, so that is address binding. Logical address bound to physical addresses. So dynamic relocation using a relocation register. So another way to do the address binding is using the relocation register. To start, consider simple scheme where the value is the base register. To start, consider simple scheme where the value in the base register is added. to every address generated by a user process at the time it is sent to the memory. In this relocation register, the base register now called as the relocation register. So you remember when we look at the protection, the memory protection, we have the base register and the limit register. So in this dynamic relocation, it has the relocation register which mapped the logical address to the physical address. And also we have the dynamic loading. Okay, until now, we assume that the entire program and data has to be in the main memory to execute. Okay, so for example, if program A has 100 lines of codes, we assume that all the 100 lines of codes must be in the memory for the program to be executed. However, dynamic loading allows a routine or module to be loaded into the memory only when it is used. Okay, meaning that it is not always. Okay, it is not always that all the programs need to be in the memory. Only the one that needs to be used will be loaded into the memory. With dynamic loading, okay, so and this is what we call dynamic loading, meaning that we only transfer codes that is required into the memory. Okay, so this results in better memory space utilization. Unused routine is never loaded, and all routines kept on disk is in the relocatable load format, and it is useful when large amounts of code are needed. So meaning that even though there is a very large program, it only requires a small memory space. Okay, no special support from the operating system is required. It is the responsibility of the user to design their program. Okay, however, OS can help by providing libraries to implement this dynamic loading. Okay, so meaning that, for example, to print, it has the printing libraries. So those are the kind of support that is provided by the operating system. Okay, so dynamic linking is dynamically link all the libraries, system libraries that are linked to the user programs when the programs are running. Okay, it is similar to dynamic loading, but linking rather than loading is postponed until the execution time. Okay, so the dynamic linking is it links all the libraries that is required by the program to execute. Okay, so this also support the shared libraries. Okay, so